On June 13, 2010, Japan's asteroid explorer Hayabusa returned to Earth. During its remarkable mission, it achieved a number of firsts in history. It was the first to fly to and from an asteroid with ion engines, the first to observe such a small asteroid up close, and the first to bring back samples to Earth. After 7 years and a voyage of 6 billion kilometers, Hayabusa came back to Earth with samples from the asteroid Itokawa, finishing its mission over Australia's Woomera Desert. Hayabusa2, Hayabusa's successor spacecraft, will soon set out on a new mission. The Japan Aerospace Exploration Agency, or JAXA, will launch the asteroid explorer Hayabusa2 into space on an H-2A launch vehicle from the Tanegashima Space Center in winter 2014. About 1 year after the launch, the explorer will perform an Earth swing-by to pick up speed and steer to the orbit of the asteroid. Then, in the summer of 2018, the explorer will arrive at the asteroid. The explorer will spend the next year and a half in close proximity with the asteroid, performing comprehensive observations and taking samples. Its return to Earth is planned for the winter of 2020, 6 years after the launch. We know from past observations that our target asteroid, 1999 JU3, is about 900 meters across and has a rotation period of about 7 hours, 38 minutes. But the only way to get really detailed information is to go there. It is a C-type asteroid, so we believe that it contains a fair amount of water and organic matter. It is expected that the explorer will gather evidence about the origin of the solar system and life itself. The first Hayabusa taught us a lot, and we used what we learned to make improvements to Hayabusa 2. The ion engines for navigation have been improved, giving Hayabusa 2 about 20% more propulsion force. They have been made more reliable to permit continuous operations during the long mission. The scientific observations of the first Hayabusa gathered plenty of data during its 3 months in proximity with Itokawa. Hayabusa 2's planned mission to 1999 JU3 will last 1.5 years. It will make comprehensive observations of the asteroid and take samples 3 times. The explorer's basic design is modeled on the first Hayabusa, although its instruments are sophisticated thanks to the vast experience gained with the older Hayabusa. The Hayabusa 2 mission has 3 objectives. Our first objective is scientific. Asteroids are believed to have remained the same since the early stages of the solar system. There is even a theory that asteroids brought materials necessary for life to develop on Earth. This is what Hayabusa 2 will encounter. When it returns to Earth with samples, the data will help scientists examine this area of research closely, taking scientific knowledge to a higher level. Our second objective is technological. Space technologies, beginning with the launch vehicles used for liftoff, offer new ways to travel into space further and more freely, and they let us do more things there. Hayabusa 2 builds on the proven technology used by the Earth asteroid return mission of the first Hayabusa. The next mission is helping to develop that technology further. And our third objective is exploratory. Space explorations are a relatively new endeavor. They extend the scope of human activity into space. We hope Hayabusa2 will establish a stronger technical foundation for future probes. The Hayabusa2 spacecraft is 1 meter wide, 1.6 meters deep, and 1.25 meters high. Its solar array paddles extend 6 meters. Its liftoff mass, including fuel, is 600 kilograms. The high-gain antenna for the first Hayabusa used X-band radio waves. One of Hayabusa2's high-gain antennas will use the same band too. The other supports Ka band for about 4 times faster data transmission. The spacecraft is also equipped with middle-gain and low-gain antennas. Selective use of these antennas in response to changing conditions will ensure communications with Earth. The Explorer has instruments to detect its location in space and its attitude. It has star trackers to observe stars visible from the Explorer and to determine its location. And it has 3 optical navigation cameras. Before touchdown, the Explorer will drop a target marker onto the asteroid surface to guide the descent to the touchdown point. The distance to the surface determined by the laser altimeter, LiDAR, and laser rangefinder, LRF, will be integrated with image data from the optical navigation cameras to make a touchdown autonomously. New instruments were developed to examine asteroid material that may contain water. The instruments include a near-infrared spectrometer, NIRS-3, and a thermal infrared imager, TIR. The optical navigation cameras will also be used to examine the asteroid surface. One of the biggest challenges facing Hayabusa2 is making a crater using a newly developed small carry-on impactor. We will observe how the crater was formed to examine conditions on the asteroid's surface and under its surface. Then, we'll try to extract subsurface material exposed by the crater. The sampler has 3 spaces to hold samples from the asteroid, 1 for each of the 3 planned sampling operations. The mission will explore the asteroid surface with 3 small rovers called Minerva-2 and a small lander called Mascot, developed by Germany and France. After touchdown on the asteroid, the rovers will move about on their own. The Hayabusa2 project receives cooperation from 3 main sources: from NASA of the United States, from Europe, especially Germany and France, and from Australia. NASA cooperated very closely during the first Hayabusa mission, especially by letting us use its communications network. We have antennas in Japan, which allow us to track a spacecraft for only about 8 hours each day. But with NASA's antennas as well, we can track a spacecraft 24 hours a day. That's critical for times like the launch, the arrival, touchdowns, and the return to Earth. We're collaborating with Europe for the first time in Japan's space exploration. A small lander called Mascot that Germany and France made for Hayabusa2 will land on the asteroid and get plenty of data directly from the surface. Germany has the advanced technologies needed to make such a lander. Like during the last Hayabusa project, the re-entry capsule will return to Earth in the Australian desert. The Australian government has agreed to cooperate with us fully. Many scientific milestones have been achieved from asteroid observations and samples from the asteroid Itokawa. Going to a far-off asteroid and returning with samples of it for the first time. These are tremendous technological challenges. and our success in meeting them has brought worldwide admiration. Many countries are now involved in unmanned missions to explore space, including asteroids, the Moon, and Mars. Japan has gained unique exploration experience through projects like Hayabusa, Kaguya, and Icarus. For the Hayabusa2 project, Japan's development of its own deep space exploration technology aims to lead the world in that technical field. The space agencies of many countries are discussing future plans for working together on human space exploration, building on experience from the International Space Station project. Japan, too, is expected to contribute to international space exploration as a member of leading nations. The Hayabusa2 project sets new challenges for Japan's unique technologies. How we face those challenges and how we use project results will surely bring new impacts to the world. The Hayabusa mission led to the Hayabusa2 mission, so meeting one challenge takes us to the next. That's how technology advances, and it demonstrates how we can learn more about our strange and wonderful solar system. It's essential that our search for answers not end with the Hayabusa2 project, but lead to more exciting challenges. Hayabusa2 is a really complicated spacecraft, and it's amazing we've been able to get it ready for liftoff in just 2.5 years. It stands as proof of Japan's manufacturing and industrial capabilities. JAXA has pulled out all the stops for this project. The Hayabusa2 project presents new challenges. It holds one key to discovering more about the origin of the solar system, Earth, and life, and how they evolved. Hayabusa2 will set out into space aiming for scientific progress for mankind and for the further development of technologies for space travel and exploration of the universe.